We go to the next. By the end of this class, hopefully that you can explain the application, the purpose of measurement first. The second one is you can elaborate the main structure of the measurement system. Okay, we have two things: the basic structure of the measurement system, and the second one is auxiliary function. The auxiliary one, I think I will not go deeper on that one. We'll go to the basic function. So the thing is, I will give you key this semester for sensors. I will give you key to unlock a few doors, so that later on in the future you can use the key to open a lot more information. Also, you can go deeper inside. If you have doors inside the doors, you will use the same keys, but it depends on that key. If you got 100% or best marks with this subject, you will have a master key lah. Master key, you can unlock all the doors. But if you cannot achieve a satisfactory level for this semester, you might need to have a very small key lah. You can only unlock a few doors only. Okay, so that's why you have to pay full attention on all these things so that you can get the master key for the measurement. Because engineers is about measurement. You analyze. Before you analyze, you have to measure first. So that's why very important this subject, although it's just 2 credit. Why? Because of this, we do measurement every day. We do measurement every day. We measure the body weight. We measure the vibration, pressure, velocity, room temperature. Every day we measure. In fact, when I want to stand up here, when I want to sit down, I do measuring. I'll do measurement. What else? Apa lagi? Saya nak, when I was stand up, while I'm standing up, not using anything, not doing anything, I'm also measuring. So can you have? Did you know what I'm doing now? It's actually my brain is analyzing the position using human gyroscope. Human gyroscope is continuously sensing the position, the notation. Either I was in X direction or Y direction or Z directions, so X, Y, Z. Continuously doing that. If you fail to do that, you got vertigo. Is it correct? Vertigo, kan? Vertigo. So you suddenly feel that you are lying down, although you are actually standing up. You feel that you are laying down. So it's not synchronized between your eyes, your fields, and then after that your brain cannot think more deeper on this situation, and then you get vomit because of that. And then so go further. So why we do measurement? Because of in measurement, because of this. First, we want to give the value. We want to give a value to everything. We as a being, human being, do measurement. We giving the value, but value we give to the brain. We don't know which value we're giving to the brain. It depends on your sensitivity of your skin, of your senses inside your body. You're giving the values to the brain. So now, but for the sensors that we want to develop, they will produce that value. That very clear value. Okay, for example, the length. Okay, the temperature. We will give the clear value to that physical quantity that you want to measure, and then from that one, now you understand the relation, the behavior of the variables that you measure. For example, the variable. When I say variable, later on we will have a look on what is variable. Variable mean physical quantity that varies. For example, length, it varies. Okay, it varies. Your weight, it varies. Different people, different weights. And then so that these variables, it will interact between something else. For example, my height. my height will interact with the size of the cars. Okay, you have a lot of people when you measure, when you design a car doors or cars, the height of the car. So you have to know the measurement of people that will be used using the car, the vehicle. So that quantity will have apa tu panggil relation. So we have to need to, when we want to understand the relation, we need to do some kind of measurement and experimentation lah sebenarnya. Experimentation. So that's why it's very important. You have to measure the value, and you need to establish the relation of the value between physical quantity to other physical quantity. So these two things is the function of the measurement. Okay. So sensors is inside that measurement. Okay. So okay. So again, the deeper explanation on that is we assign the specific value to the physical quantity. You establish a physical quantity, and then you put a value on it. And then now come to the second explanation is provide the quantitative information. So that's just technical words. The slide before this is just a layman words, layman term, and this is more to the technical words. Assigning specific value and provide the quantitative information to the physical state that we want to measure. Okay. So when we understand that one, now we can have a set of mindset. What kind of sensors we want to design later on? Okay. Well, this is quite boring stuff. I think you just can refer to this one later lah. Huh? But I just want to pick a few things I want to explain that's related to us, which is this one. This one, and this one, and this one. The bottom one is actually very important to us. Testing the materials, because we are producing different materials every time. Because you are automotive engineers, you like to have new materials every time you want to design a new cars. For example, you move from the conventional internal combustion engine, move to the electric vehicle. You need to have a different kind of materials to produce a car, isn't it? So you need to have a testing. So test require you to have a sensors, and you require you to have like quantity and the physical behavior that provided by this quantity lah. Tak apalah tu, this one more like imagine, maybe I myself only understand this one because it's already built in my mind. You only just listen to me, but later on when we look to the laboratory, then you can understand what I'm saying right now. And then this one, verification of physical phenomena. This one related with the PhD student and master student, because they are actually studying the physical phenomena. When you introduce new materials, there might be some phenomena happening. So when they want to study that one, they will need to have like experiment, and then need to use sensors to verify that one. In fact, let me give you stories. Back of the old time, we have three physicists, great physicists. First is Galileo Galilei. They are more to the observation. They're looking to they look to the phenomena, and he explains things with the science. So this is Galileo Galilei. Before that, that depends on people's opinion, religion, and whatever lah. So by the time of Galileo Galilei, he start to have a modern thinking of science, looking at physics, thinking that this is actually something have pattern. For example, the motion of the planets. Even he discovers the planets by using the telescope, isn't it? Looking telescope, And the weird thing is when you look at the telescope and then saw the planets actually not moving from this side to that side. It's moving just only this part. Every day we observe like the brightest planets. What's it called? The brightest planets every morning and Venus, isn't it? Venus. Is it Venus? Betul. Is it Venus? Apa? The brightest stars, the brightest planets. Every evening, every morning, he saw the motion of that one. The motion of one only just a few parts of the night sky is moving. That's only that parts. It doesn't move the whole parts of the sky. That's proof what? From that one, it proved that Earth is not center of the universe. Because Earth is center of the universe, what happened? That thing will move from that side around sky and to that side. So that's by the observation, measurement, looking from telescope and observe, take data, it make a conclusion that actually Earth is not center of the universe. Alright? By simple observation, okay? And then we go to the next era, which is Isaac Newton, whereby he introduced mathematics to the scientific observation. Okay, for example, the most remembered phenomena, historically, is the apple falling down from the tree, isn't it? The one, but people don't know that after he saw the apple fall down from the tree, actually he saw what? How there? What's that? No, that one is the conclusion from the apple falling down. But after he saw that apple fall down, what else he saw after that? He saw the moon. Look at the moon. Oi, apple fall down. But why the moon is not falling down? Isn't it? So that come to the conclusion that there is something as pulling, some force pulling. Although until that time, Isaac Newton still puzzled, don't know to explain the gravity. He introduced the gravity. By introducing the gravity, he can calculate all the motions in the platform of Earth. Platform of Earth, because platform of Earth, because Isaac Newton doesn't think about outside the Earth yet. But in this platform, it's always related with gravity. So he can predict the motion of everything by using gravity. But that one, because of he want to calculate why the moon doesn't fall, because if moon fall, it will go straight away to the ground. But the problem is moon falling, but not straight away to the ground. It's falling around the Earth. Around the Earth. Okay. But he's using that one not by observation, by the calculation as well. He introduced the calculus, the trajectory of the moving Earth. So Isaac Newton introduced the calculus to study the motions of everything, of physical things. And then come to the next era, which is of course, Albert Einstein. Okay, people claim he's the brightest people in the world, but there is someone else actually. But the most popular one is Albert Einstein. He introduced way further interesting way to think about the universe, which is by introduced by explaining what is unexplained by Newton. Apa dia yang unexplained by Newton? Is the gravity. Newton introduced the gravity, but cannot explain the details of the gravity, but it's being detail explained by the Einstein. What is the gravity? But the thing is, in the Einstein era, it's not physical. It's more to the something that's non-visible. Now this is come to the measurement. To prove the idea physical things need to have measurement, because at the era Galileo Galilei, you can observe things, see things, you can feel, you can have a look. Isaac Newton, you can see, you can calculate, but in the era of Albert Einstein, you cannot see clearly, you only can imagine. For example, light, how fast the light travel from that part to that part. And then, for example, if you are in the train, you can see the light. If you see the lightning, you can feel lightning at the same time, isn't it? But the thing is, you're moving towards the lightning, and you're moving. We have two lightnings. You are in the train. There's one lightning over there and one lightning over there. You're moving to that lightning. So what happened is you move toward lightnings, but people outside the train will see that the lightning at the same time. But you, in the moving train, you will see which one comes first. The front comes first, isn't it? So that's the kind of feelings. How to measure that one? How to prove that one? That come to the sensors. Come to these sensors. And another thing is to prove the gravity can curve, can make the space curve. This is the new things that you will learn after this. The gravity makes the size of things, the mass, curve the space. What Albert Einstein do is, Albert Einstein says that when lights travel to the space, it's actually moving on the space kan. Imagine this is space ni like a stretchable space. So imagine that if you looking at the although you go to the museum, some museum have this kind of things to explain, whereby we have earth like a ball. You put it on the sheet of plain cloth. Okay, you put earth ball on the sheet stretchable cloth. What it do is just bend the cloth, isn't it? So if you throw the marbles around it, it will move around it, isn't it? So this is how planets moving around the sun. Okay, so but there is non-observable. Nobody can see that one. It's only theories. So how to prove that one? How to prove? What Einstein do is, Einstein used the brighter stars that have a very bright light travel towards the Earth. What happens is, if an object covers the light from the stars, what happens is you cannot see the star, isn't it? But the thing is, you still can see it, because the light come and then bend around this curved space. Understand? So right now you see the lights from the projector. It goes straight to my eyes because nothing in front of me. So it's towards the space. So if you have a very large object, very few object, it will bend the light. But the object must be very, very big lah. For example, the sun. So what else? How Einstein want to prove this one? He wait until the gerhana matahari. What do you call that? Eclipse, isn't it? Eclipse. Because without the eclipse, you cannot see the stars behind the sun, because the sun is so bright. So you cannot see the stars behind the sun. So you wait until the eclipse, and then you see the dots of stars around the sun. So you're measuring that one. You're measuring that one, and suppose that the stars is behind the sun. But by measuring during the eclipse, it sees that actually that stars is actually plotted around the sun. Although by theoretically it's actually supposed to be behind the stars, behind the sun. So that's how Albert Einstein proved the idea of gravity. So by telling this story, now you see how important the measurement, how important to plan for measurement. Otherwise you cannot prove your theory. You see how big the experimentation, the equipment that being used by Albert Einstein. What he used? He used the sun. He used the sun. The eclipse only happening how many times per year? Just a few times, isn't it? And then if you plan the eclipse to have, let's say in July, at that particular time, 8 minutes, and during the 8 minutes, cloud coming. You plan for the experimentation for the 2-3 years, but at that particular time, the cloud covers the sky. So this is actually but that time the equipment is very minimum. Technology is very minimum, very low. But now you can do measurement every day lah. Okay, so that's the thing, that evolutions that I want you to understand is actually how this measurement is being planned. And by looking at this story, now you can have like imagination further when you study electric car, or let's say beyond that. Electric car is what, I don't know, maybe you have some ideas later on. You have to imagine, when you design something, you have to test that one. So the testing too, how to do that, how to do the testing, is depend on your creativity to do testing, depend on the technology that I have in that period lah. So itu saya nak, just want to just motivate you the importance of understanding the measurement, and now later on the sensors. Okay, we engineers usually we divide instrument or whatever things that we want to design into blocks. You have blocks. For example, this one, look at the first one. We have 4 blocks. First is sensing, second one is signal conditioning, the third one is signal processing, and the last one is display. So these 4 blocks is inside of a full objects. We call it instrumentation, instrumentation lah, full instrumentation. So inside this full instrumentation for measurement, there's 4 important blocks. Now we're going to go to each blocks in details for today lah. Okay. The auxiliary tu tak apalah. I think auxiliary tu just it's not really fundamental, but it's important as well. But we're going to have to look it not as important as the first one. Okay. Now I put it into blocks. I say block because this is actually the term that I'm going to use maybe in exam, maybe in a quiz or assignment. We call it basic building blocks for measurement. Okay, for example, we have a process or measurement or whatever things that we want to measure, and then we have a measurement system, and then we have the output that come out from the measurement. So measurement system will put the value to the physical process. So now we want to design that measurement system. Okay, tak kisahlah measurement system tu. For example, the case for the Einstein, the measurement system is the sun, the eclipse, okay. The film that you want to take a picture of the sun, the eclipse, the situation. So that's actually the measurement system. It depends on whatever thing that you want to measure lah. So it is set up. But the measurement system must have these 4 components. First, the sensing element. What things you want to use for sensing, and what thing that you want to use. If you have a sensing element, now you have to make sure that the physical quantity that being captured by the sensor, you must have a conditioning. Make sure that the signal good enough. Either you want to see, look with your eyes, or you want to put into the computer for the signal processing. Then you do, after each conditioning, well, then the signal is good. If you low power, you have to amplify. If you have a lot of noise, you have to filter. Then you go to the next one, is the signal processing element. This one basically a computer, digital, and after that data presentation. You present the data either in the screen or whatever lah methods you want to present. Now okay, these things again, I leave it for you to read this one, because this one just a statement of what I explained just now. What is instrument, what is measurement, and what is signal conditioning, what is signal processing, and then what is human observer. I want you to show you this one, the next one. Okay, this is the example. Maybe it's not really clear. Maybe in the notes, yes, you can see very well. The transmission path of the physical quantity that you want to measure. For example, this is the physical quantity. You have a lot of physical quantity you can measure. For example, force, velocity, pressure, displacement, temperature, water flow, air flow, whatever, acceleration, strain, voltage. All these physical quantity, you go to the first parts of the instrument, which is the sensor. The sensor can be divided into two parts. First, primary sensor. Second one is secondary sensor. The primary sensor is the first contact of the physical quantity, and the secondary sensor usually to convert the information from the first sensor into electrical signal. For example, pressure. When you pressurize your tires, you go to the petrol station. You see the bottom tube, isn't it? You go to the petrol station. You have a pressure tire. You can see the needle come. The old style, you have a needle, isn't it? And now new style, we have a digital value showing the pressure of the tires. So before that information go to the digital display, there's some mechanism inside, which is converting from the air pressure into a motion of something. That motion of something is converted into electrical signal. So they have two kind of sensors, isn't it? So that two sensors is primary sensor and the secondary sensor. We go in detail after that, and I have an example in this slide later on. And then after that sensing parts, go to the conditioning, which is I have listed over there. Amplifier, we have filter, integrator, analog to digital converter. Okay, all these things is just a signal conditioning elements now. Okay, and then after that, now we go to the either if you need after the signal conditioning, either you need to go to computer, you need to have signal processing. If not, you bypass that signal processing, you straight away go to the display. Okay, it depends lah. Kalau you go to the temperature sensor, temperature thermometer, the normal thermometer, that one don't have computer, isn't it? Just straight away you can see the value. So I think I have the picture here showing that one. This one, okay. You have a sensor, straight away to the display. So no need conditioning, no need processing, just straight away to the display. But still, you need to understand that all these things have blocks. It depends on the technology or the situation that you face during your measurement. Okay. All right. So you understand the blocks, and then you can build your sensors depend on the block. Make sure that you have everything. If you build your own sensor or your own measurement system, make sure you have all these things. First, sensing parts. You have signal conditioning parts. You have signal processing and display element. You have to declare all these things in your design. So that when you declare all these things, now we know, okay, now maybe you have a big department. One department is in charge on the signal conditioning. Departments depend on the design display. Okay, but most of the time for me, when I design my system, I do only for the sensor and signal conditioning. For the display, I just outsource to the other people. Now, okay, this one maybe you can read in the notes. Sensing element is the first process that sense the measurement. The measurement is the physical quantity that you want to measure. Okay, this is actually what I explained just now about the primary sensor, about the secondary sensor. Okay, all right. Usually the secondary sensor, it come out the electrical output as the output, electrical signal as the output. And then this example I shown just now. Okay, now this is very important. The transducer versus sensor. You can Google this one easily. You can see what is the difference between transducer and sensor. But this is actually confusing. The sensor is the sensor is actually a physical device that convert that the first thing that sense the changes, okay, or length or temperature, it first thing. But if you refer to the mercury, the bulb from the temperature thermometer, the mercury bulb, it the first element that sense the changes of the temperature, okay, and it convert to the expansion of the mercury. So that's the sensor. Basically, it only sense the changes. It sense the changes only. Sense that's the keyword. Sense the changes of the physical quantity. Okay. The output from the process, it doesn't matter. Either it's electrical or it just simply just a physical changes only. Kalau if apa lagi sensor? Maybe size, your body size. If you see somebody else being fat, so it's actually eat a lot, isn't it? Is it can be used as a sensor? People size? No. It depends, isn't it? But normally we see fat people eat a lot, isn't it? So that can be a sensor lah. I just want to put that can be a sensor, okay. But you know, this is actually a long time ago lah. I just make example lah. A long time ago. For example, apa lagi about physical. I don't know. I mean, I don't have an experience. Maybe about pain. Kan? You touch something, maybe sharp things, or maybe you hot things. Okay, like fire. You measure how big the scream. If they scream a lot, that means it's a lot of pain. So you establish the things by using physical. Okay. Apa lagi? That's the thing. Kalau you hear the scream a lot, that means the pain is very huge. Okay. So that's actually the sensor lah. So it doesn't matter it's electrical or not. It just change the physical quantity. And then go to the transducer. Okay. Okay. Now transducer is different. Transducer is actually it converts energy to another energy. So when you send something, you produce the energy, or you produce some information. That when we change the information to another information, now that one is a transducer. Okay. For example, if you sense the pressure give you a physical motion of something. I don't know, maybe the beam or the size of a bulb, it expand due to the pressure. That motion, the strain motion, it convert into electrical signal. So that one is a transducer. Okay, so that's the difference between sensor and transducer. Sensor is converting physical quantity into physical quantity, but from transducer is from the form of energy output from the sensor, it convert into another some sort of energy, another energy. Okay. Okay. So itu that's actually the difference between transducer and sensor lah. Some people say that's the same, but for me it's not the same lah. Okay. Okay, the desirable characteristic of transducer. I think I leave it to you to read, and then I think this is quite common. You can understand it well. It's easy to understand. You can, because there's a lot of things here, but I just want to pick a few things. A few things. First, sorry. I want to pick a few things here that's very important, which is the first one. It only can send a specific measurement sensor. So we don't want to have a sensor. When you sense something, it sends something else. For example, if you want to sense pressure, at the same time, it can show the temperature. So that's one is not good sensor. Okay, you have to make sure that only one physical quantity that be measured. And then the other one is the sensor that you use do not changing the physical nature of the physical quantity that you want to measure. For example, you want to measure the length. You want to measure the length, you put sensor. When you put sensor, the length is expand. What understand? Should be that when you measure the size of something, the sensor will not change the size. But the thing is, it change the size. So that's not really good sensor. I think this one is not a good example. I think the best example is about temperature. Temperature is common because when you implement temperature, the sensor itself sometimes produce heat as well. So when it produces heat, so increase the temperature. So that one is not a very good sensor lah. Either you have to put some isolation to make sure that the sensor will not introduce the heat to the temperature that you want to measure. Okay, and then for me this is very important, the reproducibility, the precision. It must have a very good reproducibility and linearity and so on. All these things we're gonna see the next slide. Okay. Okay. All right. So that one end for the first block, sensor block. I will go to the further on that one later on in the next lecture, which is this Thursday. Okay, this Thursday we start at 8:30 to 9:30. Hopefully that we can finish this first lecture notes. Okay, now we finish for the sensor part. Details coming later, but next Thursday we're going to see on the signal conditioning. Okay, again this is actually the first two the first slide. The first slide is more to the terminology, okay, more to understanding. Quite challenging for me because I want to make sure that everyone not boring for this one, no calculation involved. Okay, but at the end of this we have a quiz. You can see it straight away today. We have a quiz. Okay. Basically that quiz usually is in the midterm exam. Usually that kind of sort of example is in the midterm exam. Okay, so I still cannot get the attendance sheet yet, but never mind. I believe everyone is here. Maybe some of you is not here. Some of us, I think just 3 persons here. Your friends is not here?
No, they have a question with the supervisor.
Oh, alright. That's okay. So it's okay.
Next time they will join.
Oh, no worries. It's okay. But it's okay. I will not take the attendance because I failed to have the attendance sheet. No worries. So we meet again on Thursday I also try to check the location, because I think the BK5 and BK6 is for German subjects. Okay, BHA. So we can have either this one or that one. Okay, so any questions? No? No, sure. Okay. So thank you very much. See you later. Bye. Assalamualaikum.